Hi everyone, my name is Amir. I'm a PhD candidate at Delft University of Technology. It's my pleasure to present the FASTEN project for OW2 online conference. In this talk, first I talk about open source software, package management, and package dependency networks, in short PDNs, the current issues with PDNs, existing solutions, and the root cause of the issues. And I will present the FASTEN project, its solution, the FASTEN architecture, the current state of the project, and finally I will talk about some examples of the FASTEN workflow. Nowadays, software developers reuse code to reduce development costs, and open source software and libraries are hosted on centralized repositories such as Maven and PyPy. Thanks to the open source software, the dilemma of collaborative development is now possible. Open source libraries and software are considered as a building block for creating new software. However, when there are hundreds of thousands of software packages out there, the package management becomes an important issue. And basically, there are some package managers out there to help developers resolve dependencies and download required libraries for their own software. For example, we have an example here. SLF4J is a Java package, and basically it's a POM file here. As we can see, there are dependencies for SLF4J. For example, log4j is a dependency for SLF4J package. And the important part is that the log4j is also a Java package, but it has its own dependencies as listed on the right side. When there are hundreds of thousands of packages out there, basically it creates a huge and complex networks. And basically each package has its own versions, which makes things more complicated. Because of the complexity of the PDNs, recently we saw some big failures. For example, leftpad project in 2016, which made a large number of websites back then unavailable and down. Another important failure was the Equifax in 2017, which affected around 147 million of people in America, and their credit card information was revealed. Basically, the recent failures that I mentioned happened because of the issues with the PDNs. From a developer's perspective, there are basically four problems. Observability, which means how can I know a package is outdated, or the update problem, how can I check that an update doesn't break my current software. And the trust problem, which means that how can I trust code on the internet when I have important data on my own laptop or PC. And from a maintenance perspective, again we have the update problem. How can I know that if I update the dependency of my package, it doesn't break the clients and the user who use my own library. And the deprecation problem, for example, if a developer removes a feature from a library, it may break the client's program. And for example, the lack of incentive, which means that the developers spend their own free time, but they expect some kind of income or money while working on the open source software. There are some existing solutions out there for solving the issues of PDNs. For example, we have some services like GitHub and Dependabot. But usually these solutions have their own problems. For example, they do not support for assessing updates. For example, if I update a dependency for my own package, basically they don't tell you whether it's safe to update or not. Another issue is no help with impact assessment. For example, if I change a function in my library, how many clients will be affected after that? And they may produce some false positives Basically they recommend you to do something that basically you should not do. The root cause of the issues that I discussed with PDNs comes from the fact that the current approaches, they examine the problem at the package level. For example, here we have app version 1, which depends on library 1 version 3.2. But this approach only looks at the problem at the package level. However, there are another solution which is called dependency networks, CDNs. This approach is more precise because we examine the function calls in the packages, which basically gives us more insight and information to solve the issues with the PDNs. Inspired by the issues of the PDNs, the FASTEN project launched in January 2019. It stands for Fine-Grained Analysis of Software Ecosystems as Network. And the main goal of the project basically is to solve the issues of PDNs by making package management more robust and intelligent. And basically we create a centralized service to host the graphs and serve the analysis. And the consortium that we have right now consists of several universities and several companies in industry. Basically, our solution provide more precise license compliance. For example, we help developers to know whether they violate copyrights or not, and we provide more precise risk profiling. For example, we help developers to know whether a security vulnerability affects their packages or not. And we provide a more precise change impact analysis. For example, how many packages will be affected if I change a method in my own library. And the ultimate goal of the FASTEN project is to integrate the solution with the current package managers that are out there right now, for example, PyPy and Maven. And this is our ultimate goal. This is the overview of the FASTEN architecture. On the left side, we have data streams that consist of package repositories from PyPy, Maven, and Debian, and Rust Cargo, and we have vulnerability information from CVE and NVD. On the middle, we have the FASTEN server, which consists of call graph generators. Because again, the FASTEN solution is based on the CDNs, we examine the issues of the PDNs at the function level rather than at the package level. We have an analysis layer which has several components such as security, compliance, quality and risk, and change impact. As I mentioned in the previous slide, the FASTEN solution provide more precise impact analysis and license compliance and security and quality assessment. And we have a storage layer which consists of two databases, one for storing graphs and another one for storing metadata of call graphs. And on the right side, we provide basically a web UI and REST API to help developers use our own toolset and solutions that we provide. And basically the continuous integration servers can also benefit from the REST API that we provide. As I mentioned in the previous slide, the metadata database is an important part in the architecture. It basically stores the metadata of the call graphs that we generate for packages. For example, we have a table packages which stores information about the package, and we have another table for package versions, each version of basically a package. And we have a modules table. For example, in the case of Java, a module corresponds to a class. And to store the call graphs, we also have callables tables which represent the nodes in the call graph, and we have edges table for storing the edges of a call graph. And on the right side, as shown, we have files table for storing files of source code files. Since the project started, a year and a half is past. At the moment, we have alpha version of the project. One of our main achievements was to generate 1.2 million Java call graphs. to the best of our knowledge, this is the first time that in the software engineering community, basically more than 1 million call graph is generated. And we also generated 80,000 Rust call graphs. And we also generated call graphs for Debian packages. We deployed the FASTEN server on Kubernetes clusters for scalability, which helped us to generate more than 1 million call graphs. And we made the initial implementation of a storage layer available. We have basically the storage layer, as I mentioned before, it consists of the metadata database, and it has a graph database for faster access. Now we have provided some examples of the FASTEN workflow. For example, here we have an example for PyPy, which has a tool named Pipe to update the packages and to install packages. For example, after the FASTEN integration with the PyPy, basically a developer can update the dependencies of his or her package with confidence without worrying about the breaking his own package. Another example is to decide whether to use a library or not for a software package. Again, after the FASTEN integration, basically the developer can see the security vulnerabilities of a package and basically whether it's safe to update, whether it's safe to use a library or not. And thank you all for listening to this talk and your attention. If you have any questions, please check out our website for more information. And we made our tool set open source and available on our GitHub organization.